Okay, our next kind of material is polymers or polymeric materials. And basically we're talking about plastic and rubber. All plastic, all rubber falls into this category. And it says that it's mostly organic. So what are they talking about there? Where does plastic and rubber come from? Those are petroleum products which come originally from oil, which comes originally from decomposed carbon. So that's why they're saying here that these are mostly organic elements. They're low density, and they have a lot of really great mechanical properties that we use for all sorts of things. They're very flexible and they're very elastic, like rubber bands. We can bend them and they pop back, like the sole of your shoes. It bends and then it pops right back to where it was. And there's basically two kinds of polymers that we're going to talk about. So when you're taking your notes, polymers, then it goes down to plastics and elastomers. So plastic is the first kind that we're going to talk about. And then we're going to talk about a couple of kinds in this group here. We have thermoplastics. These are ones that you heat them up, you shape them into the shape you want, and then you cool them down. We can recycle these 1,000 times by just reheating them and shaping them into new things. The other kind are thermosetting, which means once we've heated it up and made it into the shape that it is, it can't be reheated and reshaped. This is why some kinds of plastics, you'll see the little recycling symbol on them, and you're always wondering, well, why can't I recycle this one? Because it's one of this thermosetting kinds that can't be reheated and reshaped. Well, why would we want to use these? Well, we use these in applications where we do want to be able to heat them up and we want them to hold their shape. For example, baby bottles have to be sterilized to get rid of bacteria, so these get heated up on a regular basis. We wouldn't want them to end up deforming and getting soft on accident. Okay, elastomers were our other kind of materials, and these are basically your rubbers that we're going to talk about. There's natural and synthetic. Natural rubber actually comes from a tree, not from a petroleum product. It actually comes from a gum tree, a rubber tree. And elastomers are very stretchy. Think tires, think rubber bands, the soles of your shoes. Very stretchy. We also have vulcanized elastomers. These have had a chemical process done to them. So they've actually been immersed in chemicals to make them harder. For example, tires. Okay, our last category falls under organic. And here we're talking about things that once are or once were living things. Paper comes from trees, food, and then materials like cotton, silk. These are all organic. They can be genetically altered. You've all heard of GMOs, genetically modified organisms, and they're renewable. We can make as much cotton as we want easily. Trees for paper is a little bit trickier, but we can also get paper from other organic sources. And they're sustainable. Not only can we make it more, but we can keep making more for as long as we want. Okay, composite materials are the last one we're going to talk about. And remember, these are really a combination of more than one of the other materials. Not really a separate group, but just a combination of one or more of the other groups. For example, these fiberglass boats here. Fiberglass is made out of glass, literally spun into fibers, mixed into polymer that makes up the resin or the glue that holds it together. Okay, the first kind of composite we're going to talk about is layered composites. And you'll notice my little plywood here going together and apart in its little layers. And this is basically what layered composites are. For example, this is plywood. What it looks like from the edge, you can see the little layers there. And this is showing actually how they make it, is they make these separate layers of wood by cutting the wood very, very thin. And then they glue it together to make this. And in the case of plywood, they're running it like this, where it's a laminate with the fibers running in one direction, and then the next layer runs in the next direction. This is to increase the strength in the plywood. Basically, wood is very strong along this axis here, but it's very weak if I was to pull it on both sides there. So by layering the layers back and forth, we've created layer strength in both the X and the Y direction there. We can also have layered composites that look more like this, where they're wavy layers, and we often see that in things like this, where we've got different layers of fibers stacked up together. Our next kind of composites are particle composites, and I have a couple examples here. This is a close-up of concrete. Concrete's a good example of composite because basically we have particles, in the case in concrete, sand and rock particles in there. We call that aggregate. And then the matrix that it's put in, the glue that holds it together, is actually the cement. We also have two examples here. This is a type of steel, and it has a matrix that's actually ferrite, iron, and then it has little particles of the cementite, which is brittle, inside there. That actually adds strength to the whole thing. Here's also an example of a car tire, where we have a matrix of rubber, and then we have little bits of carbon that are stuck in there that makes it stiffer and not so rubbery. Our last kind of composites are fiber reinforced composites, and these are ones where instead of having just little particles, we actually have little bits of fiber in there. It can be little bits that are all in different directions like this, discontinuous fibers, or it can be long continuous fibers like this. We see this in fiberglass, where it's actually little strands of glass that have been pulled into little strands and put inside a glue matrix. Or we also have a wood example here. This is called OSB, and that's where it's taken little bits of wood, little pieces of wood, and they're just all pressed back together and held together with glue. Okay, that's it for composites.